What we're working with today is section 6.1, which is perpendicular bisectors and angle bisectors of triangles. And so this is when we're first starting to get into dealing with special segments and triangles, and so these are the first two we have. So an angle bisector, remember, it just says what it does, and it's going to bisect angle of a triangle. And so if this is my angle bisector for A, it just goes here and it cuts that angle in half. Equidistance is a definition you might have had before, and equidistance is just when things are equal distance from each other. So if this is the same as this, those are equidistance. Perpendicular bisector is if I have a segment. A bisector means that it cuts it in half, so I'm going to have two equal parts. And then it's perpendicular, so it makes a right angle. Okay. The first rule that we're going to have is dealing with perpendicular bisectors. If I have a perpendicular bisector and I connect it to these endpoints of that segment that was bisected, then this segment and this segment is congruent. So a lot of times you're going to see a picture drawn and you're not going to know, it's going to say this is 5, and you're going to have to know what this is. Well, if this is perpendicular bisector right here, then these sides are congruent, so this left side is also 5. So let's go ahead and look at these first three examples. I'll zoom in for you. Okay, and so finding A to B, well, see if I can find a highlighter. A to B is right here, which is exactly what we set up there, so that means it's the same as this one. And so this is 9. And the reason I know that this was a perpendicular bisector because I have a right angle here, but 6 is equal to 6. So that means D was also the midpoint, which means it was bisected. Okay? For number 2, it's kind of the converse where it's telling you, oh, these sides are equal. Well, if these sides are equal, that means that this right here has to be the perpendicular bisector. And so that means I know it's perpendicular, but that means that these two are equal. So if E to H is 3, then H to G is 3, and so then the whole thing is 6. And so E to G is 6 because that segment was bisected and gave me half, which is 3. For number 3, we take it a little bit further because I have x's and I need to solve for x because this is what I'm looking for. Well, this left side is equal to the right side, so that tells me that this is a perpendicular bisector. And so that means that these two pieces should be the same because that segment was bisected in half at U. So I'm going to say 3x is equal to 2x plus 2. I'm going to minus 2x on both sides, and I get x is equal to 2. Now here, it's not asking me to solve for x. It actually asks me to find SU, which is that whole thing. And so I need to plug this in. So I'm going to do 2 times 2 plus 2. That's a lot of 2's. 2 times 2 is 4 plus 2. So SU is equal to 6. So these are the three different types of problems you can have with perpendicular bisectors. Either the bisected segment's equal, or the left side and the right side is equal, the point that touches where the perpendicular bisect is. All right, the next three examples, I don't know what I did, but it skips number 4, so we're just going to leave it like that. These are angle bisector problems. And so I didn't talk about it up here, but let's go back and look real quick. If this is an angle bisected, right, then what should happen is if I draw any line perpendicular to one of the sides, then those have to be equal. So I'm going to kind of erase those because I don't want it to get confusing. But when I go from the perpendicular bisector to the sides of the angle, if I make them perpendicular, then those two pieces have to be equal. So looking down here, it might make a little bit more sense. Since this piece, C to D, is equal to D to B, that means that these angles have to be equal. So that means if this bottom angle is 20, this top one's 20. And then now if I want to find the whole thing, like it says, C to A to B, it's both of those, so 20 plus 20. So the measure of angle CAB is 40. Okay, for number 6, it shows me the angles are equal, but it's asking me to find D to C. Well, if the angles are equal, then this piece that's perpendicular is also equal. So this is also 5. So D to C is 5. And then the last one, these arcs mean that they're equal, and there's perpendicular lines, so that means that these are equal. And so I'm going to set up 5x minus 1 equals 3x plus 1, minus my 3x on both sides. And I'm going to get 2x minus 1 is 1. Now I'm going to add 1 to both sides, and I get 2x is 2. And then to get rid of that times 2, I divide by 2, so x is 1. Now you have to be careful, though, because that's not my answer. My answer is asking for BD, which is right here. So I need to plug that in. So it's going to be 3 times 1 plus 1, because instead of x, I plugged in what I found for x, which was 1. 3 times 1 is 3, plus 1, so BD is equal to 4. If I asked you to find what DC is, you should recognize, oh, those have to be equal, so DC is also 4. You could take the time and plug in 1 here, but 5 times 1 minus 1 is just 4, so there's really no need. So the big things to know for perpendicular bisector is if you have a perpendicular bisector, then the sides that come off the perpendicular bisector are congruent. And then the same thing here. If I have angle bisectors, then the sides that are perpendicular that come off are equal.